also got to train Optimus to use its limbs and its sensors with a neural net.
Elon Musk stated. No longer following rigid pre-programmed motions, Optimus Gen 3 is now learning directly from the real world and improving every day, with over 2,000 entirely new tasks already completed. But is Optimus 3 truly capable of doing all this, or are Elon Musk's words just empty promises? Before we begin, please help us reach 13,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How did Elon Musk announce the current production status of Optimus 3? Elon Musk has just made bold statements about the future of Tesla Optimus Gen 3, the humanoid robot expected to surpass even electric cars to become Tesla's next flagship product. During his remarks, he emphasized that Optimus is entering a stage of superior design refinement.
So we're evolving the Optimus design and really getting Optimus to the point where it is a phenomenal design.
This indicates that Tesla is not merely improving the robot, but redefining its entire design with the goal of achieving the highest level of sophistication. Musk revealed that Tesla is currently at the Optimus 2.5 stage, somewhere between Gen 2 and Gen 3, and confirmed that Gen 3 will be a breakthrough.
Optimus 3 is an exquisite design, in my opinion, and will be an incredible, as I've said many times before, predictive. It will be the biggest product ever.
This isn't the first time Musk has made bold predictions, but what stands out this time is that he's not referring to electric vehicles. Instead, he places his bet on a humanoid robot as potentially the biggest product ever. Given that the Model 3 has reached over 500,000 units per year, Musk's shift in expectations toward Optimus shows his belief that the robot could eventually outpace Tesla's EV production. However, realizing Optimus is no easy feat. Elon admitted, "It's a very hard problem to solve. You have to design every part of it from physics-first principles." This means Tesla cannot simply buy off-the-shelf components like other companies. Instead, it must design everything from scratch, from control chips and actuators to sensors and the drivetrain. "There's nothing that's off the shelf that actually works," Musk stated, highlighting the project's complexity. According to him, everything from motors and gearboxes to the entire electronics and mechanical systems is custom designed, a level of investment and engineering only Tesla dares to undertake at this scale. It's not just the hardware. The AI software for Optimus is also being rebuilt based on the same principles Tesla uses in its autonomous driving systems. With over 500 million kilometers of real-world driving data from Tesla Autopilot, Optimus has the advantage of learning from a proven AI foundation. Elon described the car as a robot on 4 wheels, while Optimus is a robot with arms and legs, indicating he sees them as essentially the same kind of machine, just in different forms and use cases. Given the current development pace and the scale of investment Tesla is pouring into Optimus, many analysts predict that production could reach between 10,000 and 100,000 units per year within the next 3 years. If Tesla succeeds in hitting its target price below $20,000, Optimus could generate tens of billions of dollars in annual revenue, potentially replacing the Model Y as Tesla's core product. Moreover, if deployed in manufacturing, services, restaurants, and eldercare, the total addressable market could exceed $1 trillion. In conclusion, Elon Musk is placing a massive bet on Optimus, not as a side project, but as the central pillar of Tesla's future. His recent statements not only reflect his ambition, but also signal that Tesla is rapidly approaching the commercialization of a humanoid robot that could redefine the global automation industry. Which part of Optimus 3 is Tesla currently prioritizing in its accelerated production efforts? Elon Musk confirmed that Tesla is now entering the stage of optimizing the design of Optimus, stating, "We're evolving to Optimus design and really getting Optimus to the point where it is a phenomenal design." This statement is not only assertive, but also signals that Optimus has moved beyond the initial prototyping phase and is approaching a breakthrough design standard. From refining its mechanical components to optimizing its control systems, Tesla's goal is to make Optimus a high-performance device capable of both mass production and reliable real-world operation. One of the key challenges in perfecting Optimus Gen 3 lies in the lack of suitable off-the-shelf components for a humanoid robot. Unlike the automotive or consumer electronics industries, humanoid robots require compact, high-efficiency actuators, sensors, controllers, and mechanical systems that must function in perfect synchronization within a human-like form. There are no commercial parts available that fully meet these requirements. As a result, the development team must redesign everything from scratch, including motors, gearboxes, powertrains, and the entire control stack. This is an extremely difficult problem that demands optimization at both the physical and algorithmic levels. At the same time, training Optimus to move is equally complex. In order to use its limbs as fluidly as a human, the robot must learn how to coordinate sensor data, reflexes, and motion control through deep neural networks. This is not a matter of linear programming. It involves training a machine learning system to adapt to countless real-world scenarios. Optimus needs to learn how to walk, balance, bend, pick up objects, and avoid obstacles, all of which require real-world data and the ability to interpret environmental context in real time. Unlike industrial robots that operate in highly controlled environments, Optimus is designed to adapt to chaotic and dynamic human spaces. This makes the problem exponentially harder, and for that reason, developing Optimus Gen 3 is not just a technical leap, but a complete revolution in robotic design thinking. Everything has to start from zero. Musk emphasized that the current version is Optimus version 2 right now, sort of 2.5, with Gen 3 coming next, a version he described as an exquisite design. He added, "I predict it will be the biggest product ever." This is not merely a bold prediction, it's a strategic declaration. Musk once called electric cars a revolution, but by suggesting that Optimus could surpass Tesla's vehicles in market scale, he is fundamentally reshaping the company's product priorities. It's clear that Optimus is no longer a side project, but is being positioned as the centerpiece of Tesla's future. To achieve this vision, Musk acknowledged, "It's a very hard problem to solve." This was not a complaint, but a warning about the immense complexity of humanoid robot development. Unlike cars, where many components can be sourced from suppliers, Optimus must be built from physics-first principles. You have to design every part of it from physics-first principles. There's nothing that's off the shelf that actually works. Every motor, gearbox, power electronics board, controller, sensor, and even the mechanical structures all must be developed in-house. This highlights Tesla's choice to take an isolated path in technology development in exchange for complete control over performance, precision, and cost. If successful, this could create an unmatchable competitive advantage. Another challenge lies in locomotion and control. Musk stated, "We also got to train Optimus to use its limbs and its sensors with a neural net." In other words, beyond the hardware, the AI required to learn how to use limbs and sensors is a difficult problem in itself. The neural network must absorb millions of real-world examples to learn how to move, react, and handle unpredictable scenarios, much like how a child learns to walk. AI training cannot rely solely on simulations. It needs real-world data, something Tesla is leveraging effectively through its Tesla diner locations and private test facilities. Musk also made it clear that Optimus's AI training approach is not entirely new, but builds upon the foundation Tesla has already developed for its vehicles. He concluded, "So the same principles that apply to optimizing AI inference for the car apply to Optimus." In other words, Tesla is not starting from scratch. The work they've already done to optimize AI inference, the ability to make fast, accurate decisions in vehicles, can now be applied to humanoid robotics. This significantly shortens the development cycle, lowers processing costs, and increases the product's real-world viability. Overall, Elon Musk's latest remarks on Optimus Gen 3 show that Tesla is shifting from the experimental innovation phase into industrial acceleration. With a design optimized from first principles, AI systems inherited from autonomous vehicles, and a strategy to localize 100% of key component production, Optimus now stands on the brink of becoming the most groundbreaking product in Tesla's history. Exactly as Musk warned, this will be bigger than anything we've ever done. Once again, please help us reach 13,000 subscribers. This is important for us to stay motivated. Thank you. What makes humanoid robots a potential replacement for the electric vehicle market? Tesla is gradually transforming from an electric vehicle company into a robotics-focused conglomerate, with Optimus Gen 3 emerging as its next strategic product, potentially even more important than the electric cars that once made Tesla a household name. This shift is evident not only in Tesla's product showcases, but also in how the company is allocating resources, building new production lines, and outlining long-term goals for scale and profitability. If the 2010s were defined by the rise of electric vehicles, the post-2025 era may well be remembered as the moment Tesla fully committed to the age of humanoid robots. In terms of market potential, humanoid robots offer opportunities that far exceed electric vehicles in both scale and diversity of application. While the EV market is currently centered around individual consumers and transportation businesses, robots could be deployed across hundreds of industries: manufacturing, healthcare, restaurants, hospitality, retail, education, even home assistance for the elderly or people with disabilities. Research institutions estimate the humanoid robot market could surpass $10 trillion in the coming decades. In contrast, even with rapid growth, the EV market remains confined to a more limited scope, with global revenue projections capped at around $950 billion by 2030. This means that even a small share of the humanoid robot market could generate revenue far exceeding Tesla's current earnings from electric vehicles. Another key reason Optimus could overtake EVs as Tesla's flagship product is its superior profit margin and scalability. In the automotive industry, profit margins are typically modest, especially for mass-market models like the Model 3 or Model Y. The use of complex components, compliance with safety regulations, after-sales maintenance, and high production costs all contribute to relatively low net margins, typically around 10 to 20%. In contrast, once humanoid robots are standardized and mass-produced, they could achieve margins exceeding 40% thanks to simpler assembly, lower maintenance costs, and greater utility value relative to price. To pursue this ambition, Tesla is expanding Optimus production lines following a similar playbook to the gigafactories built for EVs. In the US, the first dedicated facility aims to produce 10,000 Optimus units in 2025, just the beginning. The Giga Robot Factory model could be replicated in Europe, China, and other high labor cost regions, where companies are more willing to invest in automated labor replacement. Unlike electric vehicles, which depend on charging networks, regulatory permits, and specialized infrastructure, the Optimus robot can be deployed directly into homes and businesses, enabling much faster scaling. Moreover, the upfront investment for an Optimus robot is designed to be lower than that of an electric car. According to recent statements, Tesla aims to price the robot below $20,000, potentially even lower if production reaches millions of units per year. A robot capable of working 8 to 16 hours a day could replace 1 to 2 full-time human workers in standard environments such as warehouses, factories, restaurants, or nursing homes. With average labor costs in the U.S. ranging from $40,000 to $60,000 per year per full-time employee, the return on investment for one robot could be under 6 months. This presents a far more compelling economic model compared to EVs, which often take years to recover their initial costs through fuel savings. Beyond economics, Optimus also has the potential to reshape how society perceives work itself. While electric vehicles primarily address issues of transportation and environmental impact, humanoid robots directly influence the structure of the labor force. When deployed in repetitive, hazardous, or basic service roles, robots can free up humans to focus on creative, strategic, or emotionally supportive jobs. This could spark a wave of investment in robotics across service sectors that have traditionally been difficult to automate using conventional machinery. In essence, Tesla's investment in Optimus is not just about launching a new product, it's about redefining the company's mission and the future of work. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.